theme. I got on another black ball sweatshirt, and I hope you've got on your black ball gear as well. So we started off thinking about perimeter and area, then we thought about area of combined rectangles, right? So having to find a shape that's got more than one rectangle in it, trying to find the area of that. Now, in real life, you are not always going to have all of the measures of a shape that you need in order to do whatever you're trying to do with that shape. So, for instance, I've got two examples. So let's start with this first one. So, for instance, let's say you're in math class with Miss Gluskin, right? And she says that you're going to be building this mural, and the area of the mural is 54 feet squared. Awesome. You know your area. She tells you the base of the mural is 9 feet. You're going to be working on this with other fourth graders, and everything's great and awesome. You get started, and you're starting to plan, and you realize you're missing a piece of information, right? You realize that you don't know how tall that mural is going to be. What's the height of that mural, right? That perpendicular line segment from one base to the next. We don't know what that measure is right now. So we can represent that with a variable, right? Let's call it n. You could call it x, you could call it h, any lowercase letter, right? So our variable is n in this case, right? So we don't know the measure of n. We don't know the height. And so what we can do is we can go back to that formula that we have, right? We know that the area formula is area equals base times height. Now, if you have at least two parts of this formula, you can figure out the other part. So I know that my area is 54 feet squared. So I'm going to substitute in that number for that A that's representing area right now. So I'm going to call this 54, right? Then we know the base is 9 feet. That was a piece of information that Miss Gluskin gave you. What you don't know is that height, right? So I've got an n to represent that unknown number, right? N in this case means some number, right? So 54 equals 9 times some number, or the product of 9 and a number. Well, think about that. What number and 9 create the product 54? You should know right away that that answer is 6, right? You know that 9 times 6 is 54. And so what that means for us is that our height, this missing measure, this unknown measure we didn't have originally, is 6 feet, right? How do I know that my unit is feet, right? Well, I know that 54 is 54 feet squared. The way I get feet squared is feet times feet, right? So 9 feet times 6 feet equals 54 feet squared. So my height, my missing height is 6 feet. All right. Now we can also do this not just for area, but we can also do this for perimeter. So now I want you to think about this. Let's say you're building a fenced-in area for a garden or a dog, right? And let's say I tell you you're going to use 24 meters of fencing. Your area that you're going to be fencing in, it's going to have a width of 3 meters. So your width is 3 meters, and your total perimeter, your meters that you are fencing, meters of fencing, is 24. So I know if I did a quick sketch, right, it would look something like this. I've got my width of 3 meters, and then I've got 24 meters of fencing. I don't totally know how that's going to play out yet, right? Well, just like we used our area formula up here, we can also use our perimeter formula, right? So we know that perimeter equals 2 times the length plus 2 times the width, right? So the product of 2 lengths or the product of 2 widths, right? So, okay, let's look at this closer now. We know that our total perimeter is going to be 24. So just like our area formula, we're going to plug in those numbers or substitute those numbers that we know what that variable stands for. So P standing for perimeter, we know is going to be 24. The length we don't know yet, so we still have that 2 times L as our length. We don't know what that is, but we do know our width. We know our width is 3. So we can plug in that 3 for that width, right? Now we can simplify this expression a little bit because we can solve what 2 times 3 is. We know that 2 times 3 is 6. So now we have an equation that looks like this. 24 equals 2 times something plus 6. So right now we need to think, okay, what plus 6 gets us to 24? Right? So we're thinking of this as one whole unit right now. Those parentheses tell me whatever happens in there, it's going to become one number, just like that 6 became one number when I plugged in 3 for my width, right? So I'm thinking, okay, well, what plus 6 gets me to 24? You can do some subtraction, 24 minus 6, and you're going to find 18, right? So now we know that 2 times L is going to be equivalent to 18. So now we're thinking, okay, well, what is 2 times L? 2 times what is going to give me 18? 2 times what gives me 18? You should know right away, that's 9. 2 times 9 equals 18. So let's plug this in and see if that works. If we continue to bring down our equation, we have 2 times 9 plus 6, that gives us 18. Plus 6, and 18 plus 6 is 24, so that checks out. So what that means is that 9 that we plugged in for our length, that is the length of the measure of our length, right? So that original unknown number that we had as our L for our length, that's now become 9. Now, if we want to double check, we can just add up all of our sides, right? So we would have, it's a rectangle, right? So each of our parallel sides is congruent, right? That means it has the same measure. So 3 and 3, and then 9 and 9. If I go off to the side and add those up, 9 plus 9 plus 3 plus 3, 9 and 9 is 18. 18 and 6, and what do you know? We get 24, right? So, as you're finding, my friends, we can find the unknown measures of shapes using the formulas that we already know, right? Using this area formula and using this perimeter formula. If either one of those formulas wasn't familiar to you, then you need to go back and re-watch some of those videos so that you become a little bit more comfortable with them. All right, the last thing I want us to do is think about how we could draw the perimeter of a square that's 24 feet. So if I tell you the perimeter of a square is 24 feet, how could you draw that, right? I'm not giving you any information. I told you you need to have at least at least 2 of the 3 pieces of information, right? So area equals base times height. You need at least 2 of those to figure it out. And same for perimeter, right? You need to know at least the length or the width or the perimeter, right? You need at least 2 of those things. We only have 1. How could you figure that out if it's a square? What do you think? Pause me here and try it on your own. So hopefully you pause me and you try this out. You should know a square means that all of these sides are congruent. They are all exactly the same length, which means that I need to take that 24 and split it into 4 equal parts, right? If I take 24 and split it into 4 equal parts, what do you get? Well, we know that that would be 6, right? 6 and 6 is 12, another 6 is 18, and our last 6 is 24. So we know that this square would have lengths of 6 feet on each side. All right, my friends. So you're going to have an opportunity to add on to what you've been working on, trying this out on your own. Can't wait to see all your hard work. Thanks.